Okay, so my name is Thierry Laronde. For the people who didn't hear my name before, I will just make a quick talk about tech on Plan 9. In fact, I will focus only on some misunderstanding. There is tech on Plan 9 because there is a distribution now that is called CareTech, and I'm the creator of the distribution. Plan 9 is not regarding tech second-rate citizen. CareTech is totally up to date with Satan. Plan 9 does not lag behind. And since Geoff has spoken yesterday, he mentioned TeX in the end of the paragraph about escaping APE, and TeX was mentioned. I will explain why APE is in the picture. This is totally the reason is very slight, in fact. And the main reason why APE is here is because CareTech is available for all VOSs, in fact. I cover Android, all the Linuxes, all the BSD, Plan 9. Windows will not be very difficult to add to that, but since Microsoft has done things so that you can directly add a Linux distribution on it, there is also tech with CareTech on Microsoft. API is used only for compilation because I have this wide range of OSs to deal with. So I used, in fact, POSIX.2, the userland, a subset, a very small subset of utilities, and POSIX utilities, but this is just for the compilation. In fact, and this is what Donald Knuth wanted at first, TeX is in fact using only the live C. Only the live C, and as Geoff has spoken about yesterday, I'm only using the live C with a standard C from 1989 or 1990. So I'm totally compatible, and it is available absolutely everywhere. There is one misunderstanding, and I will now talk about TeX versus ROF. TeX is an interpreter. Now it takes 8 bits. It takes lines, but it absolutely doesn't care about the end of lines. It doesn't see the end of lines. Whatever the system, whatever the end of lines, they are in fact discarded. The interpreter, in fact, does by compiling. I will explain after what this is. What it produces is, in fact, a layout for pages. The format generates is called DVI. This is a device-independent format. This format is then post-processed by some filter. In fact, I use only in Cartec DVI PS. So we start with DVI to end with PostScript. This will go in the future. The important thing about this, that's to be called TeX, and I use uppercase later, and I use this spelling TeX. It is because it has to be it has to pass the test. There is a torture test set by Donald Erwin Knuth. If such an engine passes the test, it can be called TeX. Now, this is the interpreter. The program that we call TeX, lower cases and Latin pronunciation, is in fact not a program by itself. It is an instance of the interpreter, but that is using the digest of a set of macro done by Knuth. Text is in fact virtex. I will explain what it is regarding this using plain text set of macro. There is byte compiling made by the TeX engine. In fact, there are two programs. There is initex and virtex. Initex takes a set of macros and then dump its memory. This dump is called the digest, and when a program here is called TeX, this is in fact just the first argument of this is arc V0. In fact, this is a copy. This can be a hard copy of virtex, and this is the name of the file that is used to instruct virtex to load this digest. When I have something that is called latex, latex is not an engine. Latex is something like TeX. So in the very first version of LaTeX, it was virtex, but since the name of the file is LaTeX, it simply takes the digest of the LaTeX macro. What has to be remembered is that LaTeX is in fact not an engine, it is a huge set of macros. So we use a first version of TeX called initex to digest the huge set of macro, because this is an interpreter. It takes a lot of time to just interpret the macros. So to speed up the things, this is a by-compiling. We first digest the set of macro, then dump the memory, and in a second time, when I call latex, this is in fact just the name of a copy of Virtex. Because it is called latex, it will take the digest of the latex macro, the digest of the version by compiling to be able to process a latex file. This versus rough. Rough is also an interpreter. It has been ported to be compatible with UTF-8. So TeX taking 8 bits, this is more than UTF, can do rough. Rough takes lines, but it doesn't do by compiling. Rough constantly has to reread every file, everything. Rough versus TeX produces a set of pages too. Rough doesn't have a torture test. There is nothing telling what rough has to be. In fact, the reference is the user manual and what has been done by Bell Lab from rough to rough, renamed Trough with a version called nrough2 that is simply generating pages for teletypes. So since rough is also an interpreter, making pages, making layout, using UTF-8 that is less than 8 bits, because not every sequence of 8 bits of octet is a valid UTF-8 value. Nothing can prevent from, for example, having a program called MS that will be simply a copy of Virtex, but using a set of macro written for TeX, doing exactly the same thing that the MS macro are doing for rough. TeX is more general than rough. There are very ad hoc things done with rough, while TeX makes things a less restriction. So we can, in fact, replace rough as a page creator by TeX, simply letting TeX mastering macros like the MS macros to produce the pages. So for me, the future of TeX and CareTeX is in fact to do also what rough is doing, and since rough is not very easy to program, it is a bit awkward. TeX can be a bit awkward too. But for example, for manual pages, there is nothing that prevents using the TeX engine to do what rough is doing. This is simply converting the rough written macros, set of macros, in TeX understandable 1, you can still write main pages using the syntax of the rough macro, and it will simply render the pages. I have some things to do still, quite something to do. To extend a little DVI, because the rough has added some primitive that are not in DVI, only 2. There is some peculiarities about the lines, because a rough takes beginning of a line to detect what is a macro and not a macro, so that this can be addressed. But in fact, what rough is doing can be done by TeX. There is nothing preventing this. So TeX can be the typography of a system. To go back to what I said about APE, we wrote it. I wanted CareTech to be exactly the same whatever the system. Because if you are asking a student to write something using TeX, as long as using TeX is exactly the same whatever the system, as long as they are using mainly TeX, in fact, to produce documents, you can swap the system. Meaning that as soon as they are accustomed to use TeX, you can replace whatever the system by Plan 9, for example. They will not see any difference. The utility will be exactly the same. The commands are exactly the same. The produce is exactly the same. This is also for this that I use APE. There is a lot of details, and as you can hear, I read English without much problem. I can understand it correctly, but I speak it like a French. As you can hear, I'm not very comfortable facing an audience, so I will stop here for this point. This is the main things I wanted people to understand. There is an interpreter, but all the things that you see, name TeX, LaTeX, or whatever, or that could be MS, these are just masquerading for TeX. In fact, beneath all these names, there is only one engine. Since LaTeX has evolved, at the beginning, LaTeX depended only on TeX. Later, LaTeX asked to use extensions done by the NTS team with what is called Epsilon TeX. Epsilon TeX is an extension of the TeX engine. So I had to move to compile LaTeX, to move to the Epsilon TeX engine that is TeX plus epsilon TeX. And now LaTeX requires even other extension. So I had to write another extension, and that other extension is called prot. Prot, it is a French name, but in fact we stole it from the Italian. Well. But it is a French name. Normally the Marseillaise should... Well. Prot is an extension of a TeX engine. In fact, it is an extension of TeX and epsilon TeX. So in TeX, when I say there is only TeX, in fact, there is only Prot. Prot is compatible with TeX. We can switch to compatibility with epsilon TeX. So Prot can be used to TeX plus epsilon TeX. And it is also compatible with all the primitives required now by LaTeX. So it is compatible with Prot. So there is one engine, even if there are several distinct, apparently different utilities. There is only one engine beneath, and it is small, and it is only libc, nothing more. It's totally portable, and it is in fact what will replace eventually ROF2 in the future. That's all. I'm sorry for the speech. I'm sorry for the English. And I just wanted to spot this thing because TeX is, there is a lot of details to go into. So I just wanted to spot this thing so that you can understand a little bit to what I'm aiming now. Thank you.
Are you open for questions?
So for portability reasons and maintainability, have you looked at, and I have no idea whether it's what quality it is, but things like Protect that's written in Go, that's the essentially TeX interpreter written in Go, that's a new effort.
I want to stay with C because it is simpler. There is, for me, absolutely no reason to switch to another language. Knuth, as written, in fact, is the main objective initially was this. It happens that ROF, in fact, was written before TeX was written. So we must make allowance to ROF. It is older. And Knuth benefited from lessons learned by ROF. Knuth, at one moment, was presented with a printing of his main work, The Art of Computer Programming, and he disliked it. Why? Because the technology has evolved, and the ancient technology was not available anymore. They have switched to not digital typography, typography made by computer. And Knuth finds the result unsatisfactory. He said, if my book has to be printed this way, I don't want it. So Knuth said, I will develop a program so that no one in the future can tell me I cannot make the book like you want it. This is why Knuth has developed not only TeX, but MetaFont. Knuth had made on the layout engine, but a program to draw fonts. This is MetaFont. And Knuth has also designed fonts, the computer model. So he has made absolutely everything. And he has said, because I want in 100 years, even if all the printed version of my book have disappeared, that someone can reproduce my book exactly as I wanted it. For me, that's it. TeX is a complete solution, and MetaFont is a rasterizer. MetaFont, you define, in fact, lines, and it rasterizes the lines. It is a rasterizer. This means that in TeX, so in TeX, you have absolutely everything. For now, we rely on PostScript. There is GoScript. GoScript is a problem all by itself. It is huge. The version in Plan 9 is obsolete. It is a nightmare to update. And the license is a nightmare too. TeX is BSA licensed to MIT for prot, and it's not exactly public domain, but totally open for what the Knuth has done. So we have everything to compute the layout of the pages, everything to draw the pages, everything to obtain the image, the digital image, because MetaFont is a rasterizer. So I can replace, in fact, everything. I can go to the specification, to the file text, to the image of the pages. This is the aim. GoScript will go to. Bye. Bye-bye. MetaFont has been used to write MetaPost, John Hobby's. MetaPost is in fact a drawing program. MetaFont was specialized in fonts. MetaPost uses the same syntax, but to draw figures. The figures we have put in the paper about Nix, this is MetaPost. This is made with MetaPost. So MetaPost can be generalized. MetaPost emits PostScript commands, but it can be switched to emit DVI. I will simply extend DVI, and to rasterize DVI, I will extract the rasterizing capabilities of MetaFont from MetaFont. So I will have absolutely everything, totally independent from anything. So if in 100 years, I will probably not see the thing, if in 100 years someone wants to reproduce exactly the thing, it will be possible to reproduce it exactly using only TeX. This is the main point. So, Geoff, if I'm interested in Plan 9, this is for the very same reason as Geoff. I want things to be consistent, simple. I don't see why we have to complicate anything. We have everything here. We don't need rough and TeX. TeX is enough. We need only to take the set of macro used, for example, for manual pages. What is the problem? You use this set of macros, but TeX interprets. Why? I don't see why. So I'm hoping you see where I want to go.
So is there any way to generate plain text output from, like Rolf is currently doing? I mean, when you view a man page, your vision is that you're going to generate text to put into div text, or you're going to actually have to rasterize the page with
No.
convert DVI and use div
No.
draw.
This will be done starting from DVI. In fact, there is DVI to PostScript from now, but I will make a DVI to whatever. So DVI will make the layout, but there will be a post processor, DVI to text, to extract the text for a TTY or for whatever. In fact, from DVI, all the outputs could be made. We can go right to the bottom to the image of the pages. We can stop at some level to extract just the text or not. Everything will be done from DVI.
Okay. Because I thought of this idea too, like years ago, like why are people not using TeX more for just rendering graphical? Anytime you render text, you should maybe always use it, you know. But I don't really understand the DVI format very well, and so I just wonder, is the text actually in there, or is it actually just drawing primitives at that point? You're drawing lines.
In fact, the characters are there, but with a special encoding, because in DVI the encoding is a text encoding, but everything is possible from DVI. And I will extend DVI to cover what is possible with rough, but not at the moment possible with DVI. But everything would be done starting from DVI. One thing that could be done too, why not having a kind of utility called HTML. I have a set of macros, and I let TeX make the layout. So in a window, I feed HTML, and then I have the layout of my page according to the window. Why not?
For the deep dive, how far along are you in order for TeX to be able to parse MS macros?
Not very far. If I had the time, but I'm making too many things. I think I like everybody. I try to spare some time for Nix. I had to spare some time for CareTech to support user. I made an update for LaTeX some days ago. So LaTeX in CareTech is a very, very latest. So it's simply a matter of time. And if we can finally gather attention to Plan 9, and to this, I can have gladly some help. It's not difficult, it's just a matter of a bit of time. But I think if I could work every day on this, in a matter of 1 month, this is done.
I hope you find the time. Another aspect, DVI is more a fixed layout format, and Martin Ruckert has developed Hint, which is a reflowable text format. And the question is, it seems everything is now sort of pivotal around DVI. Are you thinking about also supporting hint for a more maybe future-facing format?
This is the reverse.
Come again?
This is the reverse. Int is using prot. Martin is using my work. So this is the other way around. I made prot as a change file exactly in the spirit of Knut and the NTS team, so that anybody can use it. And this is what is done by Martin Huisman with int. Okay.
We have questions.
So yeah, we got some questions from the internet. One is it fair to say that Truff is significantly simpler than TeX?
It is yes and no. In fact, in TeX there is no preprocessor. TeX is convoluted, is making a lot for the interpretation. It can be customized a lot, in fact. Truff is using preprocessor because the treatment of the macro is too limited in Truff. And Truff has also some ad hoc limitation inside itself, especially mixing things about fonts that are not to be done here. In fact, TeX is more general than Truff. So I can make Truff. There is a little work to do, but I can emulate Truff with TeX.
All right, and one last question. That's about the audience. Is Curtec meant for academia or rather personal use or commercial use?
Everything. It is not GPL. There is a commercial version using Curtec, in fact, because the license allows this. But this can be used by absolutely anybody.
All right, then that concludes this talk. Thank you very much.